So all of these things that we talked about so far always still produce dense networks. And what do I mean by dense networks? Is networks where all the neurons are connected to each other, all the components are connected to each other. And what happens is when you have really dense networks, they take more time to train. And that's no surprise, right? Like you have more things to calculate, you have more connections to include into the calculation. And if you had less connections, we will be able to make the network faster. And how can we do that? We can do that by basically pruning the network and get rid of some of the connections that we have. It looks very dramatic in the image here when I change it from one thing to the other. But it's basically just setting some of the weights to 0 so it does not affect anything anymore. There are 3 ways how we can achieve pruning. You can just say after you train your network, whichever weight of a connection is too small, then just make it 0. So this is not really a recommended way to go, but still one way one might consider. But a much better way is to use L1 regularization. If you remember, it is a way to lower the effect of some of the weights that we have in the network. And L1 regularization, as opposed to L2 regularization, will do it in a way that will encourage the weights to be 0, so effectively pruning them out of the picture. There is also a really nice tool called TensorFlow Model Optimization Toolkit. If we have in the hands-on exercises, we will also look into how to use them. What they do is they do pruning during the training and deciding which weights to prune or which connections to prune during the training.